This is Erica Hathaway from period 5 of Mr. Greenberg's Physics C class. Alright, so today I'm going to be doing chapter 7, number 49, and I'm going to do separate videos for part A, B, and C because it's really long and complicated and my video cuts off. Alright, so the first part, A, the problem reads, a particle of mass 1.18 kilogram is attached between two identical springs on a horizontal, frictionless tabletop. Both springs have spring constant K and are initially unstressed. Part A. The particle is pulled a distance x along a direction perpendicular to the initial configuration of the springs as shown in figure 7.49. Show that the force exerted by the springs on the particle is force equals negative 2kx times, parentheses, 1 minus L over square root of x squared plus L squared, parentheses close, I, which is x component. Alright, so in this problem what we're doing is basically proving a formula that they give us by logic and stuff like that, and calculus, and things like that. This one's not so much of calculus. So first let's write down what they want us to prove. So what they want us to prove equals force equals negative 2kx times 1 minus L over square root of x squared plus L squared times I, which is x component. Alright, so what they're trying to find is the force of the spring at x component and y component. So first thing we're going to do is draw a picture. That's the most important thing you can ever do in physics and shenanigans. Okay, so if this was on an xy coordinate, right? This is our little mass m. But you're going to say mass equals 1.18 kilograms. And we have two springs. One goes this way and one goes this way. This point right here that the springs start on are both set. So they're not going to move that way. But if we pull our little mass this way in x direction for the distance x, our new picture is going to look like this. So this is our mass here. We know that this is x, correct? So our springs are going to look like this. And initially they were pulling this way, force here. Now they're going to be pulling this way, force and force. Alright, so first let's solve for the y component because that's easy. We know that the way they pull this way and the way they pull this way are directly opposite. And therefore, the y component is going to equal 0. They pull with the same force in opposite directions. That's why they equal 0. So now all we're going to do is solve for x component. Now x component, what we're going to do is we're going to solve for one spring and then multiply by 2. The reasoning behind this is they're both pulling the same direction with the same force, which is going to be the x component is going to be 2 times of one spring. Capiche? Alright, so we know that the force of a spring equals negative k change in x. Alright, everybody following me? So what we're trying to do is find change in x. We're going to plug that in. If you use the Pythagorean theorem formula, we know that our new spring is going to be, this is L, because this was the original spring, right? Now, this is our new spring. New original. Okay? So it said in the problem that the original is going to be our spring L. This right here. It's going to be L. And then if this is our change in x, this new thing is going to be x squared plus L squared. So the change in x would be it would be the new minus the old, so x squared plus L squared minus L. Get that? This one minus the original, because that's how much they were. Alright, so now we're going to try to find it in the x direction, because that would be the total. Does that make sense? So the total would be negative k square root of x squared plus L squared minus L. We're trying to find it in the x direction, therefore we're trying to find it in the I component. So what we're going to do is simply assign this theta, we're going to say it's cosine theta. Cosine theta is simply adjacent over hypotenuse. So it would equal negative k x squared plus L squared minus L times x over x squared plus L squared. That should be simple enough, right? And now we're just going to simplify in the component. So if we simplify, it's going to be negative k. I'm going to bring this x. I'm going to bring this x to the front. It's negative kx. And square root of x squared plus L squared divided by the same thing is going to be y. I meant 1, sorry. 1 minus L over x squared plus L squared. Alright. And then since we have two springs going the same way, we're going to multiply the entire thing by 2. So it's going to become negative 2kx times 1 minus L over square root of x squared plus L squared times I. That equals what we wanted originally, which is force. Ta-da! This is our part A answer. Keep in mind that we can always add plus 0j, which is the y component, but since there's no y component, why not just make that 0 and make it invisible? Simple as that. Alright, so see you guys next video, part B.